try. Anyway, we have 5 people. We have a quadrivium, a quintivium. We'll be talking about a recent programming contest and the sorts of problems they saw and how much fun it was and why we should all go to programming contests. I believe there's still some pizza left in those stores.
This is only 30 minutes, 5 people. We need to be very fast. It is about being fast. But okay, Dr. Calvert is saying, okay, Professor Jaromczyk, you need to use a microphone. Okay, thank you, I will. Okay, so it's everything about being fast. Let me introduce the speakers and then I will start with a short introduction. You can sit later and then I will be inviting consecutive presenters. So, okay, Peter Bifone, okay, contestant, part of the team. Ivan Tony, previously on our team, now an assistant coach. Tanner Willis, student, sophomore, I will stress. No problem. Okay, Brandon Bultman, you are currently junior, but not yet. Sophomore, okay, still sophomore. So it will be relevant at some point when I will be making comments. So we'll have brief presentations about the problems in a moment, but I would like to make, just to start with a general introduction to put you in the context what the contest is about. So if you just would like to sit down now, okay, I will. So really just I need to move fast for that, I apologize. So how to move, okay, but I may need to ask you, okay, Brandon, to move maybe slides, okay? If you could stand here and move slides. So, okay, so I wrote that abstract. I really would like to talk about how I'm viewing this ongoing process and activity of the university that started in the 80s, actually, of the last century. I was reminded by one of our graduates, okay, and this continuing under different formats, of course, but okay, we went through a number of different sponsors. The most recent sponsor for at least this national level is the National Security Agency, which will play some role in the later part of this presentation. Okay, what is important for me is that we are able to keep it alive. It's not trivial to keep activities alive. In many schools, okay, it is totally driven by students, but for that, we need to have successes, okay? And this new format of the National North America Championship, which is a new format in the sense that previously, okay, if you could flip, okay, this is just our team in Atlanta, Georgia, okay, let me start with the general reason for being a part of the competitive programming. Some people, when you are looking at Wikipedia, you will read that it is a sort of a sport. It might be a sport in the sense that we need to be stronger and faster, but not in the sense of esports. It's a different reason, and I'm trying to list those reasons. So really just learning more, okay, becoming stronger problem solving, to improve your abilities to solve algorithmic problems. That's really the key to everything. Becoming faster and more efficient programmers, working on a team where you need to manage time, resources, limited resources, one computer for 3 people, okay, are under stress. And because of all of the above, it's a really just learning, becoming a better professional. And for that reason, and it will be also presentation of sponsors and career fair element of the competition. You know, just really, there are some organizations that are recruiting mostly from people who have some exposure to this competitive programming. There are many of those listed. I will not go through where now you can Google for competitive programming and you will find a list of resources. But it is, there are many, many ways to practice. It is because it is important for some employers. It's also kind of a good test who would be a good prospective software developer and problem solvers. Okay, the ICPC is one of the international collegiate programming contest. It is a foundation now. It's one of those places. It's the oldest. It's really targeting the universities. Okay, and what the process is that it used to have 3 stages. Now it has 4 stages. The first one, and for me the most important, it's an acronym. I didn't have first space, so okay, UKY-SPC, which is University of Kentucky Students Programming Contest. It's, okay, together with ACM, we are organizing that event for everyone who wishes to participate here on campus. We are forming teams. Okay, from the teams, okay, the number of teams is going to so-called regionals. For 11 years, we were organizing a satellite site here on campus in the library until they moved labs, and it was not really easy to organize the contest. So recently it was in the University of Louisville style. It might be in a different place next year, but it's not quite sure where. It is, I will stress, it's important that there are volunteers who really want to do it, because that's really just the only way of running this type of initiative at the lower levels. Okay, we advanced by participating with regionals, placing 6 as the 6th school in the mid-central regions, which gave us a path to North America, an invitation to the North America Championship. The first time, okay, we organized it because previously that level did not exist. Just the top teams were advancing to the world finals. So, okay, if you could move to the next slide. Okay, just this is a brief slide describing, you know, just okay, what was happening. 60 teams advanced. So being one of 60 teams is quite an achievement. I would like to say it's a quite an achievement to get off my chest. I will tell directly that we didn't do, we did not perform very well, not on the level that I would like to see. So we underperformed, which by saying underperformed means that my expectations, okay, and my assessment of the team are much, much higher. Okay, but this is an element of exercise. To use, okay, the quote, okay, the chances were there, but in the critical moment, the shots did not fall. Okay, that's just a quote from a recent broadcast on UK game. Okay, so this is how it is happening. Just many elements have to come together. So let's flop, okay, to the next one, and this would be actually you know, a transition to a presentation of problems. Let's try to make it efficient. I already used more time than I should have done. Okay. So.
But you're a professor, you're a student.
Well,
Hi, I'm Peter. I'm a senior here at UK. So ICPC, we had a huge, long schedule. We were kept busy the entire time we were there. They had morning yoga, prayer meditation, and cyber challenges, which we'll talk about later, as well as career fairs for the students to talk to the sponsors there. So the format was 5 hours, 3 teammates, and for this contest, 12 different problems. The way points are scored is number of problems solved. For tiebreaker, how early and how many you did. Like, if you submit multiple ones incorrect, you get penalized time. And that's how tiebreakers work. So the one that we solved was the mini battleship. For those who don't know, battleship is a game where you are against another player and you call out different spaces and they tell you whether they hit or not. For this problem, you're given a board with different hits and misses, and you have to come up with a number of ways the ships can be placed for the board to be considered valid. The runtime for this problem was 7 seconds. The input size was extremely small, with the max size of a 5x5 board with 5 different ships, and the length of the ships cannot exceed 5. So we decided we could just simulate the problem, that is, try all possible combinations. The code, partially shown on the right, shows that we try to generate all possible combinations. Unfortunately, it was a bit too slow. We ran it, it was about 7.1 seconds, when the time limit was only 7 seconds. Fortunately, after creating like a worst case scenario, we found an easy fix. We had a redundant if check, checking if the board configuration was valid, because we also did the same exact check here. By removing it, we saved about 0.3 seconds, and it was the difference between getting a runtime time limit exceeded error and passing the test case, which goes to show how tight these timings are sometimes. Problem of hopscotch was something that we also tried. We tried to use DFS and then later Diactros, but it was unfortunately too slow. We got time limit exceeded. Here was us showing it afterwards that we got it too slow. After the contest, we found out we could do a dynamic programming sort of solution, which just involves with trying to reduce the state by remembering different things about the problem.
So now we'll talk about another challenge during the contest. It was because of the sponsorship by the National Security Agency, there was a cybersecurity challenge. And my comment is the following. Okay, problem solving translates to domains that our students were not even exposed to. So, you know, Daniel will talk about the example problem, and okay, he hasn't, none of our students saw any kind of problems of that nature, yet because of the general ability of solving problems, they were able to tackle them.
Okay, so the night before, we had a talk by the NSA, and they basically introduced us to the challenge. And so there were two different sub-challenges, which were, one was cryptographic, and the other one was reverse engineering. So since Peter had experience with cryptography, he chose to do that challenge, and then Brendan and I were working on the reverse engineering aspect. So for our problem, we were given this instruction set, and we were asked to try to figure out how to write a disassembler for it. So we could take these instructions, and then we could turn them into something like the screen is showing, so we could output, so you could more easily read it, basically. And for the next challenge, NSA has recently developed a new cryptographic algorithm. It's called SPEC, and it runs for low-power devices. And we were tasked to take this pseudocode and implement it. That's what we did. And after the challenge was over, or before, they talked to us about Hydra, which is NSA's new decompilation tool. So it'll take, you can see x86 assembly here, and it'll take that and it'll translate it to admittedly really ugly looking C code, but you can more easily analyze binaries just to figure out what a program is doing if you don't have the source code. So an interlude about that is, I've recently seen a video of somebody who took, this is a game called Super Hexagon, and they used Hydra to analyze the code, or they just had the assembly, and they wanted to program their computer to change the color of their keyboard to match the state of this game. So it's not really, you don't have to have Hydra to do that, but it's a really cool thing.
So I made a comment about that, and they just said the sponsor, main sponsor, they are very open to working with the students, and there's a chance that someone from the NSA will visit us, will talk about opportunities, internship, participation in cyber security challenges, and I really hope that some of you will be able to attend. But we'll be not the first one. Actually, we have someone in this city here who did quite well in what was the name of it? That was this catch a flag event we had about 2 years ago. I think that we did quite well on that.
Oh yeah, the point 3 series.
Yeah, capture the flag.
Yeah.
So we have some tradition, but bringing the NSA, the organization and campus would be great. Okay, so now we are switching to a kind of general game for the students. I'm so happy to see so many students. I appreciate your presence.
Yeah, so some of the benefits at the actual conference that we were at last weekend included professional networking. So Peter kind of touched on this already with the career fairs, but we had a lot of networking with sponsors. So a lot of these sponsors are people that wouldn't even step foot in Kentucky. They like to recruit from the bigger schools. So a lot of these companies were very nice to network with, and from like a student's perspective, it's very nice to be able to talk to companies that are from like very far away in like California or New York, because we never get that interaction in the first place. So some of us networked with SpaceX. I know Tanner got to talk with the NSA about specific internship opportunities that they provided. IBM and Watson was also there, so with their quantum computing work, a lot of people got to talk to them about that. And we got to also talk to JetBrains about some of the compilers' work. And then L3 Harris is a military contractor from Florida, and we also got to talk to them, as well as 2 Sigma. So some of the impacts to students, they're pretty big actually. So nowadays a lot of companies are switching towards coding interviews for seeing how good candidates are to actually hire. So oftentimes you'll apply online and then they'll send you an actual coding assessment to see how good you are at coding. And so one of the benefits of competitive programming is that you have to memorize a lot of algorithms so that you can implement them quickly during the contest. And so with these coding interviews, the problem is you have around 2 hours to solve 3 problems, or maybe even an hour to solve 3 problems. And so you have to quickly get the solution very fast in order to advance to an actual in real life interview. Or sometimes the actual personal interviews also have these coding interviews. So it's very important to have these algorithms down so that when you go to the interview, you can actually get the job. Another benefit is critical thinking skills. So just as a little personal anecdote, before I joined the competitive programming team, I had a little bit of trouble with doing a lot of coding problems. I could get the gist of it, and after a couple hours, I could get them done. But the problem was that I wasn't able to do it in a speedy amount of time. So another benefit is that you get a lot of practice with solving algorithmic problems, so that in the future, you get to have the opportunity to solve them in a quick amount of time. Another benefit is just being better with your coursework. So last semester I took CS315, which is our algorithms course. And at the beginning, I was kind of shaky on a lot of my algorithmic knowledge, but I joined the team at the same time. And as I practiced the algorithms while practicing for competitive programming, it actually aided in my coursework for that course. So that's a little bit of an anecdote. Also, for programming projects, so typically during the contest, before we jump into a problem and start coding, we also plan the problems out and plan what we're going to write before we start writing the problem. And so that is that can be translated into your coursework as well. I know last semester, 2 semesters ago, one of my biggest problems was that I would start coding without really knowing where I was going, and then I get stuck in a weird loop. And so competitive programming really helped me with that. And then there's also just increase in overall CS knowledge, so just knowing more data structures and more algorithms can really help with your coursework. And it's also fun, so getting to just see random problems and thinking about them is really good for your brain. It's really good for your brain exercises. And then I think the last thing is just keeping us kind of humble in the aspect that there will always be a harder problem that needs to be solved. I think that's really important. We kind of learned about this past weekend, where there were a lot of hard problems that we didn't know how to solve that we need to look into and learn how to solve, so the next time we go back, we can actually do them. And so a couple things for the future, right? So first, we need to increase our algorithmic knowledge. We qualified at nationals, but unfortunately we didn't get to the next step of going to worlds. So one of the things that we need to do is hunker down and kind of just look into more algorithms to figure out our next steps. And that can be done through practice using applications like Code Forces, which is an online competitive programming website. Some of you all might have heard of LeetCode before. It's also another algorithmic website for studying algorithms. Another thing is maybe in the future expanding the size of our team. So right now we're relatively small. There's about 2 to 3 sub-teams of 3 people. So potentially having more people in the future would be beneficial for increasing our team's capabilities. And yeah, so at the end of the day, we just like to thank everybody. So the CS department did sponsor us, so we would really appreciate, or we really do appreciate that sponsorship. And we also would like to thank Dr. Jaromczyk for his coaching and Ethan Toney for his coaching as well.
So I would like to just make one short comment and then we'll take questions. So the biggest thing for me is the broader impact. One of the elements of the broader impact is translation of
one of the broader impacts is the ability to translate our solving problems skills from the puzzle level type of things to real life problem. For that comment, I would like to invite Bifone Tony, who was an undergraduate student, then graduate student. He was a contestant in the one of the teams for a couple of semesters, and then he is a software developer, has his own contracting company, as well as has an instructor experience by being a part-time instructor and teaching this semester web development. So a few words about your observations in that context.
Yeah, so they mentioned that this really helps with interviews and getting a job in industry, and I cannot reiterate that enough. I've gone to many interviews where they've actually, like one was I was at Google, and they were giving me a problem, and it was exactly one of the problems that I'd had one of my regions before. And it was fun because I hadn't actually solved it in the regions, and so it gave me like a second chance to kind of solve the problem, and I did. And so it's kind of, these problems really do come back up, and they're kind of famous in that sense, where they're very classic problems and are used in interviews in many cases. But just the knowledge you learn from all these different algorithms and how to apply them in industry and how to actually take these things you're learning in class, like depth first search and dikers, and actually implement it and have an implementation that you can reference whenever you need to do that again, really speaks a lot of weight in industry. I've used many algorithms that I've written in class for different problems that I've had to do for contracting work, especially given the fact that you never know what you're going to get whenever you're doing that kind of work. It's always different every single time. And that's really the broader impact, I think, that the competitive programming team can have in industry, and it really produces high-quality programmers whenever they graduate from the department.
We'll just switch to the next slide.
Yeah. I think that's this.
So, okay, so we are ready, okay, and please, okay, everyone.
Ready for a few questions. It's still a few minutes. I know that some of you may need to go to classes, so we understand that. So, and Dr. Hayes, please, question.
So first of all, we just want to thank you all. We're so proud of you and your accomplishments. And we just want to give you a hand. And also just a quick note, many of those companies absolutely will set foot in the state of Kentucky. So for example, NSA comes to our career fairs, L3 Harris comes to our career fairs, and Intel is our latest industry partner association member. So don't get too down on Kentucky. We definitely can attract these companies.
No, we just put ourselves on the map by
Absolutely.
participating.
So I am curious to ask you all two questions, I guess. Are there things that you could think of that we could have done to help you in some of the things that we teach in our courses, number one, or other ways that we could have supported you as a department that could have maybe made things easier for you?
Yeah, so I guess one of the biggest things is algorithmic knowledge specifically and actual implementation. So a lot of these problems, they require some level of theory behind them and knowing an algorithm and then having to implement that specific algorithm. So a lot of the times we'll implement or we'll learn about these algorithms in courses, and then sometimes we implement them and sometimes we won't. So maybe a bigger emphasis on actual implementations of algorithms. I know that sometimes it's on us as students to do that outside of class on our own, but also maybe a little bit more theoretical, or implementations of the actual theory.
Okay, please.
So I just to start with, I have kind of like mixed feelings about competitive programming, and I do like some parts of it, and I agree with one of the things you said, like the benefits you said in this presentation. But one of the drawbacks, or it seems to me, that we talked about in this whole first half of this seminar was ethics, because when you're learning how to program algorithms as fast as possible and as efficiently as possible, and to win a competition, it doesn't necessarily teach you about the ethics of programming, how can you implement an algorithm that is private, keeps data private, how can you implement an algorithm that keeps data secure. Those answers are often not the fastest solution. You want to actually slow down your code or implement things that are not the most efficient. Do you have any comments on how that affects, I'm programming ethically.
Well, this is a difficult question, Peter.
Well, Peter,
So I'm really into cybersecurity and the whole data safety thing. So when I write algorithms for better programming, I understand that these are not good and shall be used in practice without serious revision, just because of the fastness and not as well testing as the ops should be. I 100% agree that it should be a more focus on ethics and how to produce safe, repeatable code. But sort of their test data tries to break your code in any way possible, whether it be boundaries or making sure that things run, segfaulting. They try to do that with minimum and maximum test case parameters. But I do agree that it should be a bigger focus in better programming.
This NSA, okay, crypto cyber security contest, I have a few of those elements that you have mentioned. So, anyone else would like to contribute?
During the competition, what do you have available in the way of programming languages, computers, facilities?
So there are a few different languages. The ones off the top of my head I can name are C, C++, Java, Python, stuff like that. And we also get a page of 25 notes, or 25 pages of notes, which you can fill with, if you don't know how to do dragsters off the top of your head, you can put it on there. But other than that, you just get one computer, so you kind of have to optimize how, who is at the computer, who is solving a problem.
So let me add.
They were displaying during the contest various statistics. In addition to the languages that were mentioned, there is a language called Cockney. It's a functional programming language, very interesting. It's developed by one of the sponsors. There were statistics how many submissions were in various languages. Most of the submissions in C++, which we had a discussion driving back what is really the most useful language in industry, and Java seems to be maybe more than C++ now. The next was Java, C was 0 submissions, Kotlin was a little bit, and Python, surprisingly, Python 3, surprisingly very low number as well. So, there's a little bit of, just a difference between, again, what schools are teaching now and what competitive programmers are using and what industry also expecting. But that is a comment. Okay, Professor Dietz, and that would be probably the last question.
We'll pass it to
Sure.
Dr.
So I used to participate in an awful lot of the ACM programming contests and things like that. I've been involved in running a bunch of them. And one of the key things that I think always comes up is how do you structure the team so that you actually have the best team overall, as opposed to just getting the best individual programmers. So I was wondering, do you have any strategies on that?
Yeah, so that's more about the coach. Okay, it's a difficult game. It's like forming teams in classes. It's a big task. Forming good teams is even harder. It's more an art. I will not tell you all of my hints, rules. Okay, but in general, you need to have a group of people who like to work with one another. Okay, but each of them, in general, we are talking about complementing skills, but in general, all of them must be able to pick up any given task.
Well, this has been fascinating. Thank you very much, and congratulations on getting to the level that you did. So, other good news, we finished the pizza, courtesy of the industrial partners, and we'll see each other next week.
thanks, Rafi.